All right, year sevens, we're back. Welcome to your last week of this horrible, long distance learning unit where we've got parts of things. We've been through fractions for many, many weeks, and we've rushed you through decimals. We've taken you through percentages. Last and probably least is ratios, because ratios are another way of breaking something up into parts. Ratios are commonly used in real life, right? They're used in recipes, so you can put a certain amount of one ingredient with a certain amount of another one, and they're just used in any situation where you want to break something up kind of in an uneven manner. So we're going to be looking at ratios, how ratios can be used to break things up, and how we can simplify ratios just to get some more practice simplifying things down. Once we're through this lesson, you've basically learned everything we want you to learn from this unit. Maybe we'll make you do a test before you come back to school. So ratios are a pretty commonly used and commonly referenced piece of maths that can just pop up anywhere. Um, this isn't something you're going to hear any football commentator say this year, because we're not going to have anybody in any crowds whatsoever. But if supporters were allowed to go to the football, you probably would hear Bruce say something like, the Collingwood supporters outnumber the Carlton supporters 3-1 tonight. That's a ratio. That's saying that there's 3 times as many people in one good group as there is in some other stinky group, right? So we could represent that with the simple ratio 3-1, right? So what that essentially means is that for every miserable, horrible uggo over here with their stinky blue jumper on, just looking sad and terrible, having some stink lines coming off their heads. We've got 3 really attractive, intelligent, warm, friendly, happy people over here, right? 3-1, right? So there's 4 people at the football, 3 of them are Collingwood supporters, 1 is a Carlton supporter. That's a ratio, right? We made a ratio out of the football. And as I said at the start, you are most likely to see ratios pop up when you are making recipes, particularly in baking. You got to get your flour to your sugar or something like that. So we've got the chef here, scooba-doo-ba-doo, 5 eggs and doo-ba-doo, 4 cups of flour. That's a ratio, right? For every 5 eggs, there must be 4 cups of flour. It sounds like an incredible recipe. I don't know what he's making. I can't wait to try it. But basically, the more flour I put in, the more eggs I got to put in, right? The more eggs I got to put in, the more flour I've got to put in, but I've got to keep it in that ratio, right? It's not exact. There's not 1 egg for every cup of flour. There's more eggs than there are cups of flour. It's a ratio, right? And we can use that to be excellent expert chefs, just like this Swedish chef here. All right, now that you trust me that ratios are a real life thing that happen in real life and that you should know about them, you can put the definition in your glossary so you know what a ratio is. Right, you've got a section already on fractions and a section on decimals. We should write down what a ratio is and just show it. So the formal definition we'll stick with for a ratio is that it's 2 or more numbers, because we can split things up into 3 groups if we want, but 2 or more numbers that show how a whole thing is divided into parts, right? We have a visual example here. We have a 3 centimeter stretch, and we've split it up into 2 pieces, right? We've got a 2 centimeter stretch and a 1 centimeter stretch. So the ratio of yellow to green is 2-1, right? So you can copy this one down, and we'll do some examples of the work you're going to do today in a minute. Just one thing worth mentioning before we get into our work is that a lot of people, when they see ratios, because they've spent so much time studying fractions, they tend to mix their ratios up with their fractions and the way they work, especially because they've got their 2 numbers, right? Fractions, they're on top of each other. Ratios, they're next to each other. So here we've both got the number 1 and the number 3. Right, the number 1, the number 3, they mean different things, right? So with a fraction, right, the number on the bottom is your number of pieces, right? This is something cut up into 3 pieces, right? I chop my piece of chocolate into 3 pieces, and I get to eat 1 of them, right? It's 1/3. Right, we know what a third looks like. So this is the ratio 3-1. Because there's a 3 here and a 1 there, there are 2 different sides. There's 2 amounts of parts. So this isn't 3 parts like this one is. This is 4 parts, right? Because I get to have 3 of them, and you get to have 1 of them, right? So my piece of chocolate is cut into 4 equal pieces, and I get to eat 3 of them, right? So I'd much rather be on this side of the ratio. I get 3/4 of this chocolate, right? 3 out of 4 parts, than have this fraction, right? So fractions and ratios are different. You should view them differently. If I want to know how many parts in a fraction, I look at this. If I want to know how many parts are in a ratio, well, I'm going to add them together, all right? Because there's 3 on this side and 1 on that, all right? Something to keep in mind as we move forwards. All right, so when we're making ratios, you really just have to know how many parts are on one side and how many parts are on another side, and then you can just chuck them in your ratio, and then we'll see about simplifying in a minute, okay? So if I had to make a ratio comparing 7A students with 7B students, well, you've just got to know how many students are in each group. So I do know for a fact that there are 16 students in one group, and there are 15 students in the other group, right? The ratio is 16 to 15, right? Doesn't mean that one group's better than another group, right? We'd like to talk about quality over quantity, right? And there's a fair bit of quality in this group of 15 students, probably compared with the 16 students over there, right? Again, it's like our Carlton supporters and our Collingwood supporters. These guys know what they're doing. But the ratio is 16 to 15 because that's how many are in one group and another group. So with 7B heads and 7B legs, we could go into the room, we could count their heads, right? There'd be 15 heads in the room. If we counted legs, there'd probably be 30, right? That would be an unsimplified version of it. Another way of thinking about it would be, for every one head in the room, there are 2 legs, right? So we could just do that from the start, knowing how many heads and legs are compared with each other. Or there is a way of turning 15 and 30 into 1 and 2, which I'll give you on the next slide. Teachers and students, right? There's 2 of us right now teaching you guys from home, and there's 31 of you, right? That's a ratio. 2 of us, 31 of you, but there's 33 parts, right? Because there's 33 of us all working together. That's how you make ratios. Let's get into simplifying. Okay, so when we ask you to simplify a ratio down, you'll be starting with a ratio that's unsimplified. It'll have 2 or more numbers in it. So with this example here, I had a push-up competition with some other guy. I don't know who that is. Just some random dude came and challenged me to do some push-ups. I did 100. He tapped out at 25, so stronger, better, fitter, faster. And with that unsimplified ratio, we want to just simplify it down so it's easy to understand. So someone like this can actually understand what happened and how badly they got beaten. You might be able to look at these numbers and see how many times more I did than someone else. That's a really good way to think about it. But at the very, very least, this is the thing you can write down in your glossary. To simplify a ratio, we look at our 2 numbers, the ones on both sides, and we find something. We can divide them both by evenly, right? So we look at numbers that go evenly into 25 and 100 in this case. You might be able to find the best number right from the very start. You might not. Okay, so I might look at this and I might be like, I know that because these numbers end in 5 and end in 0, I can divide them by 5, right? Any number that ends in 5 or 0, I can divide by 5. So I might just try dividing them both by 5 to see what happens. That'll make me a new ratio, which gives me a 5 here and a 20 there. This is a simpler ratio, it's a better ratio, but it's not the simplest ratio. You'd look at 5, you'd look at 20 and be like, oh, hang on, 5 still goes into both of those numbers. So we'll divide by 5 again and divide by 5 again, right? Doing the same thing to both numbers to keep the ratio intact and equal, right? So it makes 1 on this side and 4 on that side. What it says is for every 1 push-up that Scrawny Small Arms here did, I did 4 push-ups, right? Bigger, stronger, faster. And we can see, that from the start, right? This is 4 times as much as that, right? The ratio is 1 to 4. What you could have done right from the very start, if you know your 25 times tables, is you could have just straight away divided both by 25. Right, we're dividing both these numbers by 25. 25 divided by 25 is 1, and 100 divided by 25 is 4. We got there in the end both ways, but I just want to point out you don't have to find the best number straight away, but if you find a number and you simplify it, you better check your answer and make sure that it can't be simplified again. Okay, but that's the basic process. Get your 2 numbers, look for a common factor, something that can divide evenly, and just divide them both down until you've got the simplest answer you can. Let's make sure we can do the simplifying business. We've got the ratio 5 to 15. We've got to look at these 2 numbers, find something that goes evenly into 5 and 15, and then divide it down. Never hurts to check whether the first number goes into the second number. 5 does go into 15. 5's the best number we can divide by. The only numbers I can divide 5 by evenly are 1 and 5. And don't bother dividing by 1. It's not going to do anything, right? It's just going to keep the numbers the same. So we are dividing by 5 to simplify this ratio, right? So this one would equal 1 on this side and 3 on that side, right? So it's a 1 to 3 ratio. Same thing with this one. We can divide both by 7. So when I divide the first number by 7, I get 1 again. I divide that by 7, I get 4, right? It's a 1 to 4 ratio. With this one, 6 does not go into 15, right? So the 6 isn't going to be my best number. So I think about other numbers that would go into 6, right? Always think about the small number because it has to go into the small number to start with before it goes into the big number. So numbers that go into 6 are 1, 2, 3, and 6. So the only number of those that goes into 15 as well is 3. So we will divide by 3 on both sides. This would give us a ratio of 2 to 5. And 2 and 5 have nothing in common, so we can't simplify that one down anymore, right? You don't have to get the number 1 in your answer. With the next one, you might not know your times tables as well as me, so you might just look for ways of simplifying it a bit before you finish it off. So the untrained eye might look at this and just be like, well, they're both even numbers, right? So because I know they're both even, at the very least, I can divide by 2. And then we'll see what we get, right? So when I divide by 2, I get 9, and I get 27. Then we've got smaller numbers that are a bit easier to work with. 3 goes into both of these, but 9 goes into them both as well, right? 9 actually goes into 27, so we then carry on and keep dividing down. We divide by 9. And then we do get the ratio of 1 to 3 in our final answer. So it turns out the best number to divide by right at the start was 18, because 18 goes into 54, but if you don't know your 18 times tables, what I'm trying to show you is that it's okay to simplify in more than one go, right? Just simplify and then see if you can do it again until you can't simplify anymore. All right, so this is where it gets dangerous because we're going to ask you to learn something else today apart from simplifying ratios. You need to know how to use a ratio and split up an amount of something into its kind of ratio-worthy parts. When splitting things up in a non-even manner, so you have to figure out who gets how much out of what you start with. Okay, so in this example, I have $70, and I want to split this $70 up between a couple of people. But I don't want to split it up evenly because the two people involved don't deserve to get it split up evenly because one person works a bit harder than the other. So I want to give it to Haxterbendy and Javier Zerin in the ratio of 1 to 6, right? So one person gets 6 times as much as someone else. So what you really need to be thinking about is this process, okay? And you will have a structured question today that makes you think like this. The number you are working with is 70, and you need to look at your ratio and think about how many parts it's actually broken up into, right? And this isn't 1/6, it's 1 to 6, right? So it's not 6 parts, it's 7, because one dude is getting 6 parts of my $70, and one dude's getting 1 part of my $70, right? That means it's 7 parts. What I should then do is I should divide my $70 into those 7 parts, right? Have 7 equal piles of money sitting there ready to hand out. So when I go 70 divided by 7, it tells me that each part of my ratio is worth 10, $10. Splitting $70 into 7 equal piles gives me $10 per pile. Then I can start to give my piles out. So the Hax gets $10 because he only gets one of my piles, right? I've really gone 1 times 10 for this guy. The other guy, though, gets 6 piles, so he gets 6 lots of the 10. So that's $60 there. And then you can check that you've done it correctly by making sure that the total amount that I gave out adds up to what I started with, right? And 10 plus 60 is 70, so I'm probably right. Okay, so we must follow this thought process, right? Look at your ratio, count your parts, divide your number by how many parts there are, and then start giving out parts, like they're going out of business, right? So $10 here, $60 there. One example done, we'll do a couple more and send you on your way. So again, with these 2 examples, we're being asked to take an amount of something and break it up into just a few parts and put some parts here and some there. So you really need to follow this structured process and think about, how many parts there are, right? So how many parts? There's 8 in this one, right? 3 parts on the left, 5 parts on the right. It means we're splitting our $200 up into 8 different sections before we hand them out. All right, so a part is worth whatever 200 divided by 8 is. So that means each part is going to be worth $25. Right, you can, if you really, really have to today, if numbers that get big, you can use a calculator for this, right? So one thing in this unit so far, we'll probably let you use a calculator for if you absolutely get desperate. Try to avoid it if you can, but if the numbers get too tricky, that's okay, right? Because we're just practicing the ratio side of things, not the mental arithmetic side of things. All right, so now that we know that I've got parts worth 25, I just got to give out parts on each side, right? So the guy on the left gets 3 parts, right? 3 lots of 25. So the guy on the left gets $75, and then the guy on the right gets 5 pieces of this pie, 5 pieces of $25 each, and 5 times 25 is 125. Then when I check my 2 amounts I've given out, they do add up to $200, which means I'm probably on the right track. Right, now it doesn't have to be in dollars, it can be, 81 of anything. So again, we've got 9 parts. And I figured that out because 4 plus 5 is 9, right? So I'm splitting things up. So some guy gets 4, some guy gets 5. 9 parts. And then a part is worth 9 boogery bobs, right? 9 BBs. That's because I went 81 divided by 9, right? I figured out what piles I should be making. I've got 9 piles of 9. And then I'm ready to give these piles out, right? So this person here will get 36 BBs because that is 4 piles of 9, and this one gets 45 because that's 5 piles of 9, right? I've handed out my 81 boogery bobs. I've handed out some learning to you guys. Hopefully you've taken it in a good ratio, right? A 1-to-1 ratio for everything I've taught you. Hopefully you've learned it okay. We'll find out. We've got some questions to do on simplifying ratios first of all, and then on splitting up your ratios and handing them out in this ratio-based unequal manner, right? So good luck with it, and send us through any questions if you've got them.